Okay, this is an example from Chapter 1, something that we did in class, but I wanted to do a video of it so you could look at the video and maybe go a little bit slower through it so you can see what we're doing. And we'll start off. Here's the description of the problem. A person invests $5,500 in two mutual funds. We'll just call them Fund A and B. And at the end of the year, gets a total of $446.60 in interest. Fund A for the year returned 6.2%, and Fund B returned 9.4%. Those are both interest rates. So how much of the $5,500 did the person have in each fund? Okay, so we'd be able to figure out what the split of the original $5,500 was between Fund A and B, such that if you got 6.2% on Fund A and 9.4% on Fund B, the total would be $446.60. So when you're working a problem like this, the first thing you have to ask yourself is, what are the unknowns? What are the things we are trying to find out? We're trying to find out how much money was invested in Fund A, and we're trying to find out how much money was invested in Fund B. We'll call that X for Fund A and Y for Fund B. Sometimes in the book they switch and talk about X1 and X2 instead of X and Y. It doesn't really matter which ones you use. You could call them R and S, or square and circle, or anything. It's just symbols that we're using to represent a dollar amount that's in Fund A and a dollar amount that's in Fund B. And from the problem statement, we know that there's some relationship between X and Y. The total amount invested in Fund A and B is $5,500. So the X plus Y has to equal $5,500. That's how much the total investment was. So if you look, we've got right here X plus Y equals $5,500, and it says that, for this particular case, the way I'm going to do it is I'm going to say that Y is equal to 5,500 minus X. And so just kind of keep that in mind, is that the relationship on the total amount invested allows us to say any place that we see Y, we can stick in 5,500 minus X, and that's what Y is equal to. Now, when you invest money in an interest-bearing account like a mutual fund, the amount of interest is determined by the interest rate times the principal. Okay, so the principal is the amount you have invested, and the interest rate is the rate as a decimal, converted to a decimal. So 6.2% interest rate is 0.062, and the amount of interest on each amount is figured from that. I is equal to P times R. The interest you get is equal to the principal times the rate. So the interest from Fund A, the 6.2% from Fund A is 0.062x, and the interest from Fund B is 0.094y. Okay, that's what these two lines down here are saying. And then again, we're going to use that. We're going to use the fact that Y equals 5,500 minus X. We're going to substitute that for Y in this part of the calculation when we get to it. So all we're doing at this point is we've just summarized the information that we know about the problem. Okay, we know that X plus Y is 5,500. We can use that to come up with a substitution for Y in terms of X. And we also know that the two interest values that need to add up to $446.60 are going to come from 0.062 times X plus 0.094 times Y. Okay, this is the total interest between the two funds, and again, the problem tells us that the sum of these two comes out to $446.60. So we have X dollars in Fund A and 5,500 minus X dollars in Fund B. So for Fund A, the interest is 0.062x, and for Fund B, we're going to use 0.094y, but we're going to stick the 5500 minus x in as a substitution for y. That's where we got from our initial relationship between x and y. And so those two interest values have to add up to the $446.60 total interest that was earned for the year. And so that's what this equation is telling us. This equation has got the two pieces of information that we got from the original problem. It's got the fact that the interest from Fund A, 0.062x, plus the interest from Fund B, 0.094y, has to add up to $446.60. It also has the fact that x plus y has to equal 5,500, and what we did was we converted that into y equals 5,500 minus x and substituted that in for y in the y part of the interest calculation. So we've got a simple equation that's got nothing but x's in it and constants, and we can solve that for x. So there's our original statement. We just start off by using the distribution property, multiplying 0.094 times 5,500 and multiplying 0.094 times minus x. Okay, so using the distributive property on this piece of it, we get 0.094 times 5,500 minus 0.094 times x. Okay, so what we want to do is, use the various different tools, the different things that we're allowed to do to an equation that doesn't change the equation to get all of the terms in it that have x on this side of the equation and all the terms that have just constants in it over on this side of the equation. So now if we look at this equation here, we've got a term with a constant in it. We want to take this term here, 0.094 times 5,500, and move it to the right side of the equation. You do that by subtracting 0.094 times 5,500 from both sides of the equation. Okay, so if we do that, the 0.094 times 5,500 goes away on this side of the equation, and we get a minus 0.094 times 5,500 on this side of the equation. So now we've got, on the left side, we've got nothing but terms with x's in it, and on the right side, we've got nothing but terms with constant values in it. So we want to use the distributive property again, this time in reverse, to pull the x out of these two pieces here and isolate it as just a single x. So how does that work? It's 0.062 minus 0.094, that in parentheses times x is equal to the thing that we've got on the right hand side of the equation. Okay, so all we did was we just isolated it, so we've got a single x here. And so we want to get this equation now into a form where it says x equals some calculation that's got nothing but constant values in it. Okay, and so to do that, we just divide both sides of the equation by 0.062 minus 0.094. You can do these calculations, come up with an intermediate value. I mean, actually, at this stage, you could calculate what 0.094 times 5,500 is, subtract it from 4660, and have a different number over here. I'm just leaving all the calculations in there and just doing one big calculation at the end to figure out what x is. If you think that's too complicated for you, or you'd rather do the calculations in pieces, there's absolutely nothing wrong with doing it that way. So to get us just a x equals, we need to divide both equations by this 0.062 minus 0.094. Now, one of the things that you have to be careful of when you're dividing both sides of the equation by some value is that value can't be 0. And 0.062 minus 0.094 is not 0. It's a negative number, not a problem with that. So you do have to check that, though, when you're doing a division. So if I divide both of those sides of the equations, I get this piece over here divided by 0.062 minus 0.094. So that's my value. I plug that into my calculator. It'll tell me what x is equal to. So plugging into the calculator exactly the way it looks on the screen here, including the parentheses, I get 466.6 minus 0.094 times 5500, all that within parentheses, divided by 0.062 minus 0.094. You hit enter, and the calculator says x equals 2200, because that's what this calculation is telling us right here. It's telling us what the value is for x. Figure out what the value is for y. I just need to do 5500 minus x. So 5500 minus 2200 is 3300. So that's the amount that was invested in Fund B. So we have our answer. The amount that was invested in Fund A, which is we're calling X, was 2200. The amount invested in Fund B, which we're calling Y, was 3300. And again, this little calculation here is just 5500 minus X. And since we know what X is, we can plug that in and get a value for Y. When you're working a problem like this, in any kind of math, even the stuff that we do later on in the semester, check your work. There is a way to figure out some alternate way to determine, does the answer that I get make sense? Does it solve the original problem? What are the two pieces of the original problem? The two pieces are that the sum of x and y has got to be 5500. That's pretty easy to tell. The other piece is that 0.062 times 20 times x plus 0.094 times y has to add up to 446.6. So we do that calculation. 0.062 times 2200 plus 0.094 times 3300 should add up to my 446 times 6. You do that calculation, it does. The result is the total interest, so the answer checks out. Okay, strongly recommend that you always go back and plug your answer into your original equations. All I did here was plug that answer into this equation right here that tells us what the total interest should be. Okay, so check your work. So there's several different equivalent ways that you could use the equation solving tools to get the same result. If you're more comfortable using some other sequence of steps, or you prefer to do the intermediate calculations, you can do the 446.6 minus 0.094 times 6500 is an intermediate calculation and calculate that value out and carry it forward. I don't care, it doesn't matter. Feel free to do so. The important things, only use valid procedures. Only use those procedures that are listed that say here are the things that you can do with an equation without changing the equation. Okay, you can add or subtract the same thing from both sides. You can use the distributive property. You can use the associative property. You can multiply or divide both sides of the equation by the same thing. The only thing you have to be careful of is you can't divide by 0. Okay, and if you're dividing by something that's got an x or a y in it, make sure that there's no way that that piece that you're dividing by can be 0. So use valid procedures, get the right answer, and check your answer.